Here we are looking at Chapter 17, Section 2, Capacitance. And this section is all about capacitors. What is a capacitor? A capacitor is a device that stores energy in the form of electrically separated charges. On page 588, you can see an illustration just like this. And what a capacitor does, when you close the switch, let me grab the pen here, and when I close the switch in this drawing, that's a battery, that's a switch, the charges in the form of our electrons begin flowing through the circuit. They run around and they'll gather on opposing plates. So as you can see, these blue, which signify our negative charges, our electrons. Hello, that's not what I want to grab. Let me just reset that, hold on. The blue here, which are signifying our electrons, run around through the circuit and gather up on one plate versus the other. Now we can see that on this plate we have a charge of positive 4. You can see there's 4 there. And when you look over here and you start counting, you're going to see 4 positives and 8 negatives, so that gives you a negative 4 charge. And this is how capacitors always work. You'll always have opposing charges that are equal and opposite to one another. So we would just call the charge on this, and for charge we're going to use capital Q for charge with capacitors instead of lowercase q. Capital Q, here we would call it a charge of 4 coulombs. All right. So moving forward, calculating capacitance. Well, capacitance, which uses the variable C, is equal to charge, the magnitude of charge of each plate, divided by the potential difference, the voltage, that is causing that charge. So with our example there, if we had, say, a charge of 4, like we said in our example, and we divided by that, let's say, 4 coulombs, and we divided that charge by, say, a 12-volt battery that caused the charge, 12 volts, that would equal 4 divided by 12, a third of our unit, the farad. A third of a farad would be our unit. Okay. Now, a note about capacitance. Capacitance as a physical quantity is a physical property of the capacitor. That capacitor has a certain capacitance. It always will. You're going to have problems, especially in the homework. I think 1 and 2 and maybe even 3 in the homework you're going to have. All of them, you change batteries on them. And by changing the battery you're using, that changes the charges that build up. It changes the potential energy that we'll talk about in a minute. But the capacitance for those capacitors does not change. Capacitance is the ability of it to do what it does. Okay, and it's the unit is a farad. It's named after Michael Faraday. He did some significant work with electricity. So what are capacitors good for? Anything where you need to store a charge that can be released in a very fast way. Old-fashioned tube TVs had a very large capacitor in them. Old-fashioned light bulbs and cameras. They used to be, you would plug a flash bulb on top of the camera, and when you hit the flash, it would burn that bulb out and use it up. Well, there's a capacitor storing the charge for that flash bulb, and it was done. Today, of course, we have LED flashes that are repeatedly used over and over again. Keyboards have tiny little capacitors in them, so when you press the E button, what it does is sends a tiny little electric signal. With that tiny little capacitor, it releases that tiny electric signal, and that tells the computer E. Basically, any electronic device that stores energy while the batteries are being charged can use a capacitor for that. So how did I get fried in college? I was trying to fix my TV, and I did not know about the capacitor in there. I unplugged the TV, I pulled it apart, and started messing around in there. Well, I reached in, and I discharged the capacitor through myself. And that TV had a very significant charge. The shock was the worst shock I've ever received in my life. I've been shocked by your standard 110 volt outlet in the house. I've been hit by 220, which is what runs like our heaters in our house. I've been hit by electric fences on the farm. This shock from my television was the worst I've ever had. I felt my heart skip. It's kind of alarming. If I had a heart condition, I might have died. So if you're dealing with electronics, it's very important to understand what's going on in there. But capacitors are used in a lot of things. In terms of electronics. So we're storing energy. That, of course, means we must be able to calculate potential energy in a capacitor. So first equation, potential energy electric equals 1/2 of Q. Q is the charge on the plate times the voltage that charged it. Okay, so 1/2 of Q times voltage. Now, like our example problem, if it was 4, it's just 4. It's not 4 and 4. It's not 8 or it's not 2. It's just the charge that we talked about, 4. And if in our example 12 volts here, we would just put a 12 there. So 1/2 of 4 times 12, 1/2 of 4 is 2 times 12. That'd be 24 joules would be the energy stored in that capacitor. Okay, very simple equation. Again, how are you going to sort this from potential energy of charges? If you're just talking about a little charge, a point charge as we would call them, that's a lowercase q. If you're ever talking about a capacitor, you're talking about uppercase Q. Well, now we can also amend our equation here. If capacitance equals charge over voltage, well then charge equals capacitance times voltage. It's a little solving one equation to give you the same equation. And if we insert that in for charge right here, then don't write that down. Look, 1/2 of C times V, which we would simplify to say 1/2 of C times V squared. So there's a nice little equation for us, and you'll actually use this one in the homework quite a bit, so you want to have that written down. And speaking of the homework, on lightning bolt, there it is, right there. Page 593, practice problems 1 through 3, not the section review. When you look at the page, there's the light colored practice problems on top, and then there's the orangish brownish review questions underneath. Do not do them in the review. Do them in the practice problems up top, 1 through 3.